These first few problems, I know this is brand new, so maybe it's possible someone doesn't quite understand how to look at this yet, but it's a you get it or you don't situation. It's not a difficult idea, but very often it's just a perspective problem. You're not sure how to look at the graph to follow what's happening. So for 1a, as I approach -4 from the left, if you want to say it that way, as I go to -4 from the left, so as x's get closer to this, what are the outputs doing? Getting closer and closer to 2. So that is 2. And the limit as I approach -4 from above, so as the x's come in towards -4, the outputs are going towards 2 also. So can I say the limit as x goes to -4 is something? It's got to be 2 because they both agree. So if I drove cars, we would be staring across the chasm at each other, so we would agree on where that thing is. Right? But what is f of -4? Undefined. Yeah, is it filled in? No. So that is the point -4 too, but is it a part of the output of the function? No. There's an open circle there. There's no closed circle anywhere. It doesn't go anywhere there. Cool. I like it. By the way, where do open circles come from? What would a function look like that would have an open circle on it? Here's one. This is one. We'll graph this and look at it. This would have an open circle. Now on your graph, if you graphed it in your calculator, it wouldn't show up because the open circle would be less than a pickle. Pickle? I love that. Be less than a pickle. So, not pickle rip. It would be less than a pixel. Nobody got the pickle rip reference, let's say. What about 1? As I approach 1 from below, from this side, as I approach 1 from below, what's it look like the outputs are doing? So see how a lot of people, when I say from below, they think this, like it's a shark, it's coming up from below. But that's not the idea. As the x's go from below, it's definitely going towards 4. As it goes from above, though, for x's above, the outputs are going towards -2. Is everybody cool with this so far? You guys understand the wrong way to look at it? Hopefully nobody's looking at it that way. So can I say what the limit as x goes to 1 is? No. Yeah, it does not exist. Good. Because they don't agree. But what is f of 1? 4. Totally 4. That's where the closed circle is. So that's the value of the function of 1. I like it. And then finally for 6, as it goes to 6 from below, from below it's 5. From above it's 5. So I can say the limit is 5. But what's the function value at 6? 2. I love it. So we're gonna talk about an idea. Would you say that this function is continuous through 6? No. In order to be continuous, not only does the limit have to exist, meaning they both go to the same place, but maybe don't get there, but they also have to get there. So that sinkhole has to be filled in. Then it would be continuous. I like it. All right, so hopefully that, I know this is brand new. We just started talking about this today, but it's not that difficult as long as you're looking at the graph correctly. And the second part is also not that bad. I'm going to show you a couple ways to make it better on the calculator. Instead of just brute force doing each one, I'll show you something kind of nifty. A couple things. And then we'll look at the graph of it. So many options. The software costs a lot of money, by the way, so we just have a site license, makes it easy to less money. I always have somebody ask me, where'd you get that? Can I get that? Is it downloadable? There is I don't know if the link's working on my website. It wasn't working last time I looked, but there was a TI emulator. I think there's a lot more nowadays in the Play Store, Amazon, whatever. You can get TI graphic calculator emulators for your phone. You can't use your phone on test or quiz, but you know, what the hell? Good to have just with you. And that, you know, if you're somewhere at 7-Eleven, you have to grab something. So if I do this, now watch, this is kind of nifty. I don't know if you guys even, normally a lot of people don't know this. What's the first value? 3, right? So if I say 3, store it in X. So I'm gonna look, you guys know about the store button? So it stores it, and X is just the easiest accessible memory location because the X button's right there. You have all these other green letters as memory locations if you want to. Then I can just do the function the way it looks. Tangent, you gotta make sure that you're in radians. So now I can just do tangent of X minus pi divided by X minus pi. And that's what it is. And then you just you say 3.1 store in X. Is everybody cool with me so far? And then if you hit second enter, if you have the newer one, you can just scroll up. I can just do this again, because now X is 3.1. Bam! Is that what you guys were getting? Yeah. And then I could do, what is the next one, 3.13? Store in X, and then second enter. So in the older calculators, you had to do second enter to scroll through the last few things you did, and you can adjust them or recalculate them. So it's pretty obvious at this point, it's probably going to 1. So then if you do 3.141, store in X. Alright, I'm not going to do all this. I think you guys can see what's happening. Cool? Another way to do it, which is a little less good, I guess. See how much detail I get here? It turns out I don't really need all that much detail to see something, but it could start to be like, what if this was 44799, and then this was 44798, and the next one was 44798? I'd say, well, it looks like it's going to 44798, 1.0000. You guys understand? But if I chopped off a bunch of the end stuff, I think it is going to 1. I'd lose resolution. So what I'm about to show you is not generally good, but it's not a bad place to start. If you put the function in to y equals, I don't know how much you guys have played around with the tables, but if you go to table set right above window, you can tell it the independent variable you want it to ask you what to do. Because then when you go to graph, well not graph, when you go to table right up here, now I put all these values in. Now watch, you can just put whatever value you want in and it calculates it. That's what it means by ask. It's going to ask you, what do you want x to be? X is the independent variable. So I can just put in there 3, 3.1, 3.13. I can just put in the ones I want. Do you see how much detail I lost though? Right? So this is not good for like a problem you got to turn in, but this is not bad for something you just want to look at real quick. Now let's look at the graph. The graph is going to be kind of freaky. You should kind of expect that a little bit. Tangent's freaky already, right? For all the x's below pi, of course, it's flipped because it becomes the negative of it. X minus pi, if it's x is below pi, it's negative. Is that cool? So that's why the tangents are kind of flipped from normal back there. I want to know near 3.14. So if I actually put in here, not 3.14, 3.14. If I actually put in here, you guys know about value? You hit second, trace, calc. You can calculate the value at a point. If I put pi, look what it does. What's the value at pi? Empty space. So normally if I put a value, like if I put 4, it tells me the value of 4 is 1.348. Are you with me? So what is it telling me then if I tell it to calculate the value at pi? It's telling me that there is a open circle. It's just not going to draw an open circle there. There is an open circle at pi. So normally the bottom, with the x minus pi, there would be a vertical asymptote at pi then in general. But since both the top and the bottom have a problem at x minus pi, it turns out to be an open circle. So if I had x squared minus 1 over x minus 1, there wouldn't be a vertical asymptote at 1. There would be an open circle at 1. But you can cancel the x minus 1. It doesn't go to infinity. It just doesn't exist at that point. Are you guys somebody with me? That's where open circles instead of asymptotes come from. That's why it's interesting somebody call it a whole asymptote, which to me is like, oh shit. But I kind of see what they mean, but my God, no, not a good phrase. But it makes sense.
I meant whole. And
No,
then-
I know what you
yeah.
mean.
Okay.
But I didn't know if some teacher had said that or if that's something you came up with.
I think I probably paraphrased something
Oh.
the teacher told me.
Okay.
But, so, I'm one of the people that just put 1. When I looked at it, it said guess, I just said 1, because I know that what pi is, it's 1. But if I just put 1, rather than putting 1.001 on his quiz, but I get marked down wrong.
No. It's from the work we did, it does look like it's 1 for sure. Because it just gets so close to 1 from both above and below. Right? So if you look at the whole table, well, again, this table is not precise enough, but these values here, there's like 6 or 7 zeros, right? And every time you take a step, it gets even better. So if I would have gone to, oh shit, yeah, like 3.14, 159, store that in X. Already forgot it. 3.14159, store the next, and then I do then it's going to say 1. It's just so far down that something starts. It's beyond the resolution of the calculator. I really want you to understand the idea of seeing the pattern of what numbers are doing. They were taking huge relative steps as we were moving through this. You can't see anymore, but the one before this had a 4 and a 4 and then something. So then this step went a really big relative step. It went to 2 more zeros and then 117. Right? That's kind of a big step. So it looks like it's definitely going towards 1. If those steps are starting to slow down how much they're changing, then maybe it's not going to be 1. Maybe it's going to be some intermediate value. So in general, let me think, where's a good example? When you're trying to find the solution of a system of equations. You with me? I know it sounds like I'm changing, but I'm not really. Give me a second. If you try to do it graphically, and the answer is 1.77722296, are you going to get that if you're graphing it by hand? No. Algebra gives you the exact answer, right? You learn the elimination method, the substitution method, you do this shit, and it gives you the exact answer, right? You with me? So when I do a table of values, I am not going to be perfectly getting the answer, but you start to see when it might not be 1 is if, like I said earlier, if it was 4, 4, blah, blah, and then the next one was 4, 4, blah, it just went down a little bit. I'm like, it doesn't look like it's going all the way to 1 now. So, but then the algebra would come in and show me exactly what it is, right? Now, on this one, you're like, what algebra do I do to change into x minus pi divided by x minus pi? Oh, shit. Well, that's beyond algebra. Later this semester, we're going to learn something called, that's neat. It's called a sound. It's called L'Hopital's rule. Now, if I say that and you know what I'm talking about, do not use that before we learn it. Anything in this class, if you use it before we learn it in this class, you will lose full credit. You understand? Because there are things you learn later that's simplifications of earlier things, but you got to go through the earlier things to make the other things make sense. So there is something calculus-wise that would allow us to do this problem by hand. We can't do it yet. All right. Okay, I like it. Kick-ass. So that second problem is going to be very similar to the problems you see in section 2.1. This first problem here is going to be similar to problems you see in section 2.2. What was the other thing I want to say? And we did a little bit of, well, to be honest, we did a little bit of 2.3 when we did the factoring and canceled the stuff out earlier. You kill the problem, then you algebraically can see the answer instead of just guessing it by making a table of values. That's kind of like 2.3. So a lot of this stuff just kind of repeats itself or is kind of like builds on each other thing. So there's no real good single order to do this stuff in. So I did bounce around a little bit, but we basically did 2.1, 2.2, and a little bit of 2.3 today. So homework, you want to try to have at least through 2.1 done by like Wednesday or Thursday to be on track. 2.1. Yeah. If you can get further than that, even better. Okay. All right. And I think, let's do this. I think I do want to do this. Yeah, let's say we're going to have a quiz on Wednesday. Three, two, one. So it's going to include the chapter 1 review stuff and then the stuff in 2-1.
So up to.
Yep. Yeah.
Quiz take place at the beginning of class or?
Yeah, always the beginning, like after about 10 minutes or so of questions. So always get some time for questions, yeah.
And if you can do the homework, you should be fine for the quiz, right?
Yeah, if you could do the types of problems in the homework, you should definitely be able to do the quiz. Quizzes I definitely make very similar to the homework. Tests, I have problems similar to homework, and I have problems that use the concepts that the homework asks. Students always love to hear teachers say that shit, but oh well. You got to know the concept, not the problem. All right, guys. I think that's enough for today. Yeah, that's pretty good. Don't get too used to leaving too early, but it's not too early. Yeah, I love you. Yeah, like, not even early. Yeah. Oh, don't worry.